Welcome to another lesson with Dr. Hill. What we're going to do today is we're going to talk about acids and bases. We're going to start learning about acids and bases, but the first place we need to really start with acids and bases is thinking about water. Now, water itself is a very stable molecule. It's a very stable substance. You can tell that because there's lots of it lying around in the environment. Just off the coast here in Westray, we have the sea, which is water. So water is very stable. It tends to not get involved in a lot of chemical reactions, but it does dissolve a whole lot of stuff. So when we dissolve salt in water, we get electrical conductivity. But the interesting thing about water is that even when it's completely pure, we can still conduct electricity. So this shows that you can dissociate water into ions, which is unusual for a covalently bonded compound. That's all going a little bit into too much detail probably, but what we'll do first of all is just have a look at what water dissociates into at a simple level, because the story is a bit more complicated than that, and you'll learn about that in higher chemistry if you do it. But at a very simple level, we'll look at what happens to water, and then we might get some idea of what it is that acids and bases are all about. So let's nip over to the whiteboard and have a quick look. So here I have our lesson title, and if I take the formula for water, which is H2O, I'll just write it under here in Word. Water is a liquid, remember, at room temperature and pressure. If I can dissociate this, I can dissociate this into two ions, and this would allow me to conduct electricity in water. So let's just say I convert it into the hydrogen plus ion, an H plus ion, which essentially is a proton with no electron. So a proton is one positive, an electron is one negative. So the electron's been left on the other part of this. So this is what we call a hydrogen ion. Okay? And it's positive. And this is now dissolved in the remaining water. Not every single water molecule is going to dissociate. This is only one or two in millions and billions of them. So this is now dissolved in water, which we give it the AQ symbol for aqueous solution. We now have an aqueous solution of hydrogen ions. Well, if we pull the hydrogen ion out of this, we must be left with something else to make the whole thing balance. And what balances is a hydroxide ion. Hydroxide ion. And again, the hydroxide ion is dissolved. Now, this process happens in reverse. So essentially, we could put in the proper arrow for that reaction. But essentially, this is a dynamic process. Every now and then, a water molecule dissociates, and then it gets back together again, because these two things are driven to react with each other again. But this, as I say, the story is a little bit more complicated. So we're just going to leave it there for this lesson. Now, what's so interesting about this? Well, we'll just take that out there. What's so interesting about this is that when we talk about acids, we are talking about substances that produce hydrogen ions. Okay? Now, is water an acid? Well, you could possibly say that because it produces hydrogen ions. When we talk about bases, we talk about a substance that produces hydroxide ions. So is water a base? Well, it produces hydroxide ions. The point is, of course, that because water produces equal amounts of hydrogen and hydroxide ions, it's neither an acid nor a base. It's always neutral because they balance out. So let's have a look at this in a little bit more detail. If I take an acid, let me take an acid H2SO4. There is sulfuric acid. That's sulfuric acid. I should really use the F because they changed that in 1990. I think we all have to use the F now, but anyway, old habits die hard. If I dissociate this, I can dissociate this stuff by dissolving it in water, strangely enough. And what happens is I ionize the thing, and I get two H plus ions plus an SO4 negative ion. Okay? So let's have a look at this. This is hydrogen ion. hydrogen ions. This is now dissolved in water, remember? This is dissolved in water. And this is dissolved in water. And this is what we call the sulfate ion. I'll spell it correctly this time. Okay, so what have we got? Well, we now have a substance that produces hydrogen ions. It doesn't produce hydroxide ions, it produces sulfate ions. Now, sulfate ions don't really do very much in solution, but hydrogen ions do. Hydrogen ions are what give acids their corrosive properties, because hydrogen ions can go off and carry out reactions with all sorts of things, and that makes this mixture of ions in water very corrosive. But it's really all down to these guys. Okay, so this is what we call an acid. An acid is something that produces hydrogen ions when it dissolves in water. Now, water itself, when it dissociates, isn't an acid because it produces an equal number of hydroxide ions. Let's have a look at this. So if I take a hydroxide, let's take sodium hydroxide. Sodium hydroxide. Okay. And again, I'm going to dissolve it in water. Sodium hydroxide is normally a solid salt. I can dissolve it in water. And what happens when I dissolve it in water? Well, I get my positive ion this time, which is going to be a sodium ion. So this is sodium ion. And I also, that's dissolved in water, of course, that's AQ. And I also get a hydroxide ion. And that's dissolved in water, AQ. Okay? Okay, so is this substance an acid? Well, it's not producing any hydrogen ions, so it's not an acid. Is it a base? Well, it is, because it's producing hydroxide ions. The sodium ions in this solution aren't going to do anything. But the hydroxide ions, again, are very reactive with other substances, and this gives a base its corrosive properties. Now, acids and bases, as you know from your first and second year learning, have particular properties. They have a bitter taste, or a sour taste in the case of an acid, a bitter taste in terms of a base. But we'll go on to look at more at the properties of acids and bases later. But what I want you to notice here is that if I take a hydrogen ion and a hydroxide ion, and I mix these two things, they will come together and they will form this set of products, which can react to form water. So taking hydrogen and hydroxide together and put them together, I can remove hydrogen ions from solution by adding hydroxide ions, and I can remove hydroxide ions from solution by adding hydrogen ions. And that's what we call neutralization. But when they combine to form water, we get not much happening. Okay, so what we have here is, I'll do it in red, we have our acid and we have our base. All right, and what is it that makes them the acid and the base? This is an acid because it produces hydrogen ions. This is a base because it produces hydroxide ions. Those two things together are the ions produced by the dissociation of water. And that's the little story that I wanted to tell you in this video. I hope that I've managed to do it in less than 10 minutes. And in our next lesson, we're going to go on and look at a number of different acids, a number of different bases, and we're going to look at the pH scale, which tries to give us a way of measuring the amount of acidity or the amount of alkalinity we have in our bases. And we'll talk about that next time.